Hey everyone, today we're going to be talking about the epsilon-delta limit definition. So let's do that. So here I have f of x, which is defined to be x squared minus 2x minus 15 over x minus 5. And obviously if we plug in 5, I forgot the arrow. Wow, I'm stupid. Okay, now we're good. Obviously if you plug in 5, you get 0 in the denominator, 0 in the numerator. But as I have so conveniently graphed out here, you can see as we approach 5, it appears like we hit 8 right here. So, how do we know that we actually hit 8? Well, that's where the epsilon-delta limit definition comes into play. So, what is the epsilon-delta limit definition? Well, let's define our terms first. What is an epsilon? Epsilon looks like that. And essentially, an epsilon is a range around your limit point. So, for instance, our limit point here is 8. But if we just define it generally to say that the limit as f of x, the limit as x approaches 5 of f of x is equal to L, just capital L, then a range around L would be L minus epsilon and L plus epsilon. It's kind of like adding a value to your y. It's like y plus 1, y minus 1. You know, it's a range around y. In this case, it's just a range around 8, which happens to be our limit point. And so, I'll write that down here, equals, range. Oh, okay, I suck at writing. We're not gonna do that. Instead, we're gonna do the math way. We're gonna do the absolute value, or I guess that's not right either. Okay, we're not gonna do equals. I'm just gonna say it. Epsilon is just equal to the range around your limit point. So if we define your limit point to be some value L, then a range around L in terms of epsilon would just be L minus epsilon and L plus epsilon. Next up, we have delta. What is a delta? Well, looks kind of like that. And a delta, in this case, is a range around the point that actually makes... Ooh, I don't want white. There we go. Okay, now I want white. Okay, it's a range around the point that actually makes your function undefined. So in this case, that's 5, right? We plug in 5, we get undefined. So a range around 5, it's generally defined as like C. Like generally speaking, we can define it as C. Same way we can generally define limits as L. In this case, we have an exact value, which is 5. So a range around 5 in this case would be 5 plus delta, 5 minus delta. I should probably write that down just like I should have for the epsilon, but that's okay. So we have 5 minus epsilon over here. We have 5 plus epsilon over here. 5 plus, 5 minus. And of course here we would also have L, or I guess, yeah, we can just use 8. So we would have 8 minus epsilon at the bottom here. Up here we would have 8 plus epsilon. Now, what do these values actually mean? Why do we care about some range around our limit, other than the fact that that's literally what limits are? Or rather, I guess, the idea of limits. Some range around a value because, you know, you can't just plug in the value or it becomes undefined. So why do we care? Well, let me explain. The whole idea behind the epsilon-delta limit definition is it's kind of like a circus game, or I guess just a game. Probably not in circuses, but okay. It's like a game. So let's say that you give me some epsilon. And epsilon, as I said earlier, is just a range around your limit point. You give me some range around this limit point. So for some epsilon you give me that's, you know, greater than 0, I will have to be able to give you some delta that when you take some x value around this delta, so 5 minus epsilon to 5 plus delta, sorry, I said epsilon, 5 minus delta to 5 plus delta, if I have to be able to define delta such that I can give you an x value that when plugged into our function, it will output some output value, some y, that is within this range of epsilon. Wow. I suck at explaining this. Okay. let me reword that. Say you give me some epsilon. It doesn't matter what it is, just some epsilon greater than 0, which is just a range around the limit point. I have to be able to define delta in such a way that I can then give you an x value that falls between the range of my 5 minus delta to 5 plus delta. Of course, not equaling 5, because that's undefined. But I have to be able to produce some delta that, if I were to get some x value in that range, it falls between 8 minus epsilon to 8 plus or 8 plus epsilon to 8 minus epsilon. I am not doing a good job here. Here, let me draw these dotted lines and maybe that'll help. So the idea here is kind of illustrated properly. Not the straightest line, but you see they kind of meet here. So essentially, excluding the value of 5 itself, I have to produce some x value with the rule of whatever I define delta to be that will then fall within, here, let me highlight this strip here, or this strip here. Essentially, I have to be able to define delta in some way that whenever I take an x value in, here, let me highlight this portion in blue, in between 5 minus delta to 5 plus delta, I have to produce some x value that when plugged into our original function here, it will produce some output value that falls between the red part here, which is in between the intervals of 8 minus epsilon to 8 plus epsilon. Not a good start to this video, but let's keep going. I want white. Okay. So, bad explanation aside, maybe we can, actually get into a proof. So, how do we prove that? Well, typically with proofs like this, we start with just defining delta as delta, right? We have to prove what it is, or define what it is, so we don't know what it is. That's why we have to define it. So we're going to start by just saying, well, how do we define a distance? It's just some value minus another, and it's the absolute value of that, because we don't want negative distances. So in this case, we want x minus 5, but not just that, it's the absolute value of x minus 5 to be less than delta. This ensures that our x value, whatever it may be, will fall in between the range of 5 minus delta to 5 plus delta. So we're given this, right? If we're given this, then we want it, so I probably shouldn't do that. So I'll say here, we are given that the absolute value of x minus 5 is less than delta. What this means is whatever value we produce out of this will definitely fall between the ranges of 5 minus delta to 5 plus delta. If we're given this, we want our equation to look like f of x, the absolute value of f of x, that is, minus L, which is our limit point. We want the absolute value of this, which is the distance between our actual output value, or sorry, our function and the limit point, and we want this to be less than epsilon. I weirdly extended that. Okay. So we want the absolute value of this to be less than epsilon. Essentially, I guess I should probably read out a more formal definition. What this is basically stating is for some epsilon greater than 0, because remember epsilon is distance from the limit point, so if it's 0, there is no distance. So for some epsilon greater than 0, there exists some delta such that the x given in a range of c plus delta to c minus delta, should be the other way around. In this case, c is 5, so some x given within the range of 5 minus delta to 5 plus delta will have f of x, which is the output of our function, fall within some epsilon of L, which is 8 minus epsilon to 8 plus epsilon. So basically, for some epsilon, we can find some delta such that an x value in the interval of, like I said, 5 minus delta to 5 plus delta will yield a output value within the ranges of L minus epsilon to L plus epsilon, with L in this case being 8. So hopefully that makes a little more sense. I actually wrote that out, and it's a half-decent explanation. So these kind of imply each other. Absolute value of x minus 5 is less than delta, then we can say that the absolute value of f of x minus L is less than epsilon. So how do we actually get it to be this? Well, first, let me rewrite this one. F of x, we know, is x squared minus 2x minus 15 over x minus 5, so I'm going to write that. X squared minus 2x minus 15 over x minus 5. In this case, L is 8, our limit point. So, minus 8. We want the absolute value of this to be less than epsilon. Now, how do we do that? And we are given, like I said, x minus 5 is less than delta. Well, conveniently enough, this one's pretty easy. X squared minus 2x minus 15, as many of you will have noticed, factors out into x plus 3 times x minus 5. And, of course, as judging by the graph, x minus 5 and x minus 5 cancel out. So let me just write this. These cancel. We still have the absolute value. These cancel, and what we're left with is just x plus 3 minus 8, the absolute value of this, to be less than epsilon. So this simplifies down into x minus 5, absolute value of that, is less than epsilon. Given that these two are literally the exact same equation, minus the, epsilon delta, if the absolute value of x minus 5 is less than delta, simultaneously, the absolute value of x minus 5 is less than epsilon for every x that is not 5, because remember, even though we canceled out, the original constraint still applies. So for every x that's not 5, the absolute value of x minus 5 is less than delta. We can safely say that delta is just flat out equal to epsilon. So what does that mean? What does it mean for delta to flat out equal epsilon? Well, it means that for some epsilon you give me, whether it be 2 or 3 or 0.1, I can give a delta that is exactly the same, 2, 3, or 0.1. And so if let's say it's a 3, right, or 2. If you gave me a delta of 2, or sorry, an epsilon of 2, that would mean that 8 minus epsilon would be 6, 8 plus epsilon would be 10. Simultaneously, I would have to plug that in here. So since delta equals epsilon, in this case, 5 minus delta would be 5 minus 2, so 3, and then 5 plus delta would be 8. What that means is any value between the ranges of 3 to 8, not including 5, will produce an x value that falls between the ranges of 6 to 10 on the y-axis. So let me illustrate that out. Let me do some equations here. What do I want to erase? This stuff over here. Everything, yeah, I'll erase everything that's not delta equals epsilon. Wow, okay. Probably should just have like pre-made black boxes. Right, I'm on white. There we go. Okay, looks a little better. Oof, my eyes aren't drying out. Okay. Wrong color. My bad. Okay. So then, let me prove, or sort of try to prove that. So let's say that the epsilon equals 7. Not, okay, that's a little large. Epsilon equals 1. In this case, epsilon equals 1. Well, given by this down here, delta equals epsilon, that would mean that delta would also have to equal 1. So instead of 5 plus delta here and 5 minus delta, we replace that with 1. So I'll just write that down here. That would be 5 minus 1, which is 4. And then down here, 5 plus 1 6. Simultaneously, it's not 8 minus epsilon if epsilon is equal to 1. That is just 7. And this is just 9. So what does that mean? It means that from the interval 4 to 6 on the x-axis, not including 5, I can plug in any value within that, and it will fall between 7 to 9 on the y-axis. It will output a value like that. So let's prove that. Let's see. Some value between 4 to 6, that's not 5. Let's say, here, let's say 4.5. Alright? 4.5 is not equal to 5, so we can just factor out and cancel, and that would be x plus 3, or sorry, x minus 5. Wait, was there at the first time? No. Alright, let's start from the top. Factor this out, it's x plus 3 times x minus 5 over x minus 5. Those two cancel out. So what we're left with is just x plus 3. Yeah, I was right. I was thinking of the other one. So x plus 3. So we have this. And we plug in x to be 4.5. So 4.5 plus 3 is equal to 7.5. And, well, that definitely falls between the ranges of 7 to 9. So we have that 7 less than 7.5, which is also less than 9. So it definitely falls between those two values. Therefore, having delta equal epsilon seems to work for at least that value. Let's try a different value. Instead of 4.5, let's go 5.5. So again, we plug it into x plus 3. In this case, we would have 5.5 plus 3, which is equal to 8.5. And 8.5 is definitely between those values. 7 is less than 8.5, which is also less than 9. So it seems to check out in both cases. That was a weird check. So what have we learned? Let me try to at least give some intuitive understanding before I leave you with like the worst epsilon delta limit definition video of all time. So let me start from the top. Essentially, for some epsilon less than 0, there exists some delta such that the x given in a range of 5, or let's generalize, c minus delta to c plus delta will have f of x fall within some range of L, some epsilon of L. So basically, you give me some epsilon, and I can find some delta such that an x given from c minus delta to c plus delta will yield an f of x that is within c minus epsilon, or sorry, L minus epsilon to L plus epsilon. I hope that made sense, and I hope this check kinda gives you some intuitive understanding. Ultimately, the goal is to define delta in some variation of L. It's kind of a rule, right? Delta has to be some variation of epsilon. You do some operation to epsilon so that every value I give, barring that delta rule, will produce a value that falls between L minus epsilon to L plus epsilon. So yeah, super bad explanation, literally the worst of all time. But I hope it helped a little. Thank you for watching.